Okay, what are we doing?
First, you got to
Okay.
your whole head or just the end? Okay.
Do we put new water?
Okay. In which case are we going to reduce the
I think
water?
you use
If
the
the
bathroom.
temperature matches.
Okay. The temperature what?
The temperature goes up like 3 or 4. And then
Or if you can't even observe 3 or 4, you can still calculate it. Okay, what are we going to calculate on the back side?
just the change of temperature.
Change the temperature, what else? Heat and what units? Joules and what else? Calories. Okay, good. Here, get 2 Cheetos, 2 peanuts, 2 marshmallows. This is your thermometer. Be careful with it, it's very fragile. Okay, it's made out of glass.
No, you do.
Set it on fire first.
You can do it. Or you gotta get off.
Okay, so but that brings us to the materials we're testing today. We have, what do you guys think this is? Hot Cheetos, hot cheese puffs, or whatever you guys call them. Marshmallows, and then peanuts. So before you guys write your hypothesis, I wanted to tell you guys a little bit about each of these things. Let's start with peanuts. A lot of people think that they fall under the vegetable group because they come from plants, but in reality, they're really high in...
I think it's the feel, when you shield it around or something.
What kind of lab are you guys doing? Turn it off. Okay, turn it off.
He said the color.
Doesn't work over here.
Okay. What kind of food are you guys testing?
We're testing peanuts, hot Cheetos, and marshmallow.
Okay. Which one had the most energy so far?
So far, the Cheetos.
What was your prediction?
That's a marshmallow.
I thought the peanut was good.
No, actually,
So both of you guys are wrong?
Yeah, we were.
Okay, that's okay.
yeah.
Alright, thank you guys.
Wow.
In protein. So they're grouped oftentimes with meat and milk. So keep that in mind when you make your hypothesis. This is high in proteins. Marshmallows are basically just pure what? Sugar. So carbohydrates. Keep that in mind when you make your hypothesis. And hot Cheetos and most types of chips are made out of it's not pure corn though. It's processed cornmeal, which means they take corn, they do a lot of things to it. They add a lot of things to it like sugar, salt, and different seasoning, as you guys can see. Yeah, there's actually sugar in here. So I want you guys to keep that in mind as well. Okay, one more thing I want to tell you guys about each of these things before you make your hypothesis as to which one has the most energy. The marshmallow weighs, surprisingly this one weighs the most out of these three, approximately 8 grams. Okay? And you can tell the size is generally bigger than the other two. Peanuts, on average, each one's going to be about half a gram, okay, because they're really small. And last but not least, the hot Cheetos are about 2 grams each. So keep that in mind as well. So your next step, go ahead and make your hypothesis in an if-then statement. So if I set these 3 on fire, then blank will have the most energy. Okay, so I'll give you guys, say 2 minutes to form that hypothesis. Okay, by show of hands, I want everyone to raise their hand when I mention the food that you choose, or chose. Who thinks the marshmallow is going to contain the most energy? Okay, 1, 2, 3. Keep your hands up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 for marshmallow.
Are you gonna say
Oh, you're going to see experimentally. It's even better than me telling you. Okay, peanut. How many of you guys think the peanut? Don't raise your hand more than once. Peanut, raise your hand high. 1, is your hand up?
No.
1, 2, 3, 4, 5 for peanut. Okay, last but not least, if you think the Cheeto, the hot Cheeto is going to have the most energy. 1, 2, 3, 4. So that's 18. So that means 3 of you guys didn't raise your hand. So I'm assuming those 3 of you guys, you are unsure. Okay? But you'll find out by the end. Make sure on your DNA that you choose one. Question?
Huh?
Question, you raise your hand?
You said unsure, right?
Yeah. Okay, so by the end of the experiment, you'll have a better idea. Get out your quiz. Before we start the lab, I did want to go over yesterday's quiz, which is important for understanding today's lab. Okay, so the most common, there's 2 things that were most commonly missed. Pretty much every single person in the class got number 1 right. A calorimeter is a device used to measure what? Absorb or release. Let me ask you guys a question. So we're going to set this food on fire, and we're going to put the can up here. So are we measuring absorption or release of energy?
Absorption.
What's absorbing the
water?
The water in the can is going to absorb the heat. What's releasing the heat though?
The marshmallow.
So it's like an indirect way of seeing how much energy the food has. Okay. Number 2, pretty much everyone got these right. Q represents
heat.
M represents
Mass.
C represents
Specific heat.
Change in
Change in temperature.
Delta T represents change in temperature. What a lot of you guys, about half of you guys missed was the units. Almost everyone got this one. It's joules, grams, and what's
J over GC.
Don't say J. Say
Joules over gram per.
okay. And then change in temperature. Some people left this one blank.
C.
Degrees Celsius. Okay. Most importantly is this last problem on the quiz, because you're going to have to do that on today's lab. So I'm going to show you guys step by step how to do this one. What's the formula for heat transfer, Destiny?
Q equals, well, yeah, Q equals MC times delta
T.
Okay, yeah, so I put it on your quiz, but you still had to know how to apply this. Which of these variables were we solving for?
Delta T.
Delta T. Today, which variable are you going to be solving for?
The C.
Not C, we're going to know the specific heat of water.
Q.
Q, the heat coming from
The food.
the food being absorbed by the
Can of water.
can of water, okay? So let's plug in our values. How much heat was added?
100.
So 100 joules. What was the mass, let's see, of water? 5 grams. What was the specific heat of the water?
4.184.
Okay, on the quiz, what did I tell you guys to do though?
4 T.
So round off to 4 joules, grams, degrees Celsius. On today's lab, I don't want you guys to round off the specific heat of water. You guys are going to be allowed to use calculators. Is that clear?
Yeah.
Okay, so use the entire value. Last but not least, what goes here?
Delta T.
So how do I isolate delta T? What do I need to do?
By dividing the M and C.
Not multiply. You have to divide. So what do you divide?
100 by 5 times 4.
100 divided by 5 times 4. What's 100 divided by 20?
5.
So delta T, let me use a better marker. Delta T equals
5
5 what?
degrees Celsius.
Is this value positive or negative?
Positive.
So what happened? Did the temperature increase or decrease?
Increase.
It increased. Okay, very good. Questions on this before we move on to the actual lab? No. Okay. So I'm going to go ahead. Let's get the lab started as soon as possible because we're going to need the entire period. First thing we're going to do, we're going to read the introduction, and I'm going to let you guys break up into groups. Clear your desks. All you guys need is something to write with and a calculator. If you don't have a calculator, your phone will do.
Oh, okay.
Yeah, you don't need a scientific calculator. I'm going to let you guys self-select your groups. You guys are all grown or mature enough. So groups of 2 to 3, there's 8 stations. Once you guys are in your stations, I want you guys to go over the procedures. Once you guys can explain to me the actual lab, I'll give you guys your materials. And before you move, I have a few tips for you guys. Number 1, okay, use the paper clip. Each group is going to be given a cup that has matches and paper clips in them. You're going to use the paper clip to actually skewer the food. Based on past experience, this is one of the toughest parts of the lab. This and lighting the food. Why is it important to keep it elevated if possible, the food that is? Amanda.
So the flame can go up into the pan.
Well, that's going to happen regardless because heat rises. But what do all combustion reactions need? Well, yeah, they need activation energy, but air, what's in air? Oxygen. So by keeping it off the ground, it's going to burn more thoroughly. However, you can't really do this to the peanut, so that's one of the limitations of this lab. The peanut, you're just going to place foil on the base of your ring stand, and you're going to burn it directly on the foil. Is that clear?
Yes.
So that's the first tip. Use the skewer for the marshmallow and the hot Cheeto. Use the foil for the peanut. Question?
I was saying elevated with the foil.
That's true too. But then that doesn't allow the oxygen inside.
Oh.
You see? Next hint. You're going to be measuring out 100 milliliters of water to put into your can. If this does not lead to appreciable temperature change, I want you to redo it using 50 milliliters. Okay, so if the temperature change is not significant enough for you to observe it, decrease the amount of water, but note that in your calculations. Okay, does that make sense? Just the water, the mass of the water. Okay. What else?